Thanks a lot, Calvin, for giving my introduction to everyone. Hey, everyone. Good evening here. Yeah, well, as Calvin talked about healthcare analytics, which may help cure cancer. So we'll talk about that in detail today. So how healthcare analytics are related to each other, like what are the applications of analytics in the healthcare industry, what are the different use cases possible in the healthcare industry, and what is the impact of solving those problems related to healthcare in the industry using analytics. Okay, and we'll go technical as well, like what are the advanced analytics implementation in the enterprise, what is the architecture all about, what are the tool sets required for implementing analytics based solutions. And finally, we'll definitely deep dive into the cancer prediction using advanced analytics use case, where we'll see that how data analytics is not only preventing but also helps in a lot of cure of the cancer as well. Okay, so let's start with the introduction to the healthcare industry. I think everyone knows about healthcare industry. So it's one of the leading industry that needs high-tech technologies to improve and deliver its different use cases and solutions on, right? So definitely healthcare industry is a potential target industry for the analytical engineers or professionals to target and solve problems all. And it is divided into hospitals, healthcare equipment and services, and pharmaceuticals. So hospitals, everyone knows there are different hospitals and they require different solutions to their problems. So the data analytics can pitch into that. And then we have healthcare equipment and services, where we talk about not only the equipment of operating a person or the infrastructure required in the hospitals, but also it is about all the testing devices, imaging devices, R&D devices, which are very critical in the healthcare industry. And then finally, we have a big industry of pharmaceuticals, where all the medicines and similar biotechnology and life sciences products are being manufactured and sold, right? So that industry as well has a potential impact from data analytics. So as you see that 10% of the GDP of most developed nations is in the healthcare industry. So 10% of overall produce of a country is on the healthcare. At least that's at least according to the United Nations. So definitely data analytics is a uh, big application on top of the industry, right? So then let's deep dive into the primary stakeholders of the healthcare industry. So we have three primary stakeholders. One are the pharmaceutical or equipment manufacturers, the people who manufacture medicines or the equipments needed for taking creating a imaging device, a MRI machine, or a CT scan machine. So these are the manufacturers are primary stakeholders. And then we have providers. So providers are not only the hospitals but also the doctors. So we take when we talk about hospitalization or OPD treatment of a patient, then we definitely go to the providers, be it a hospital or a clinic or a doctor, right? So these are the second primary stakeholders, and the third primary stakeholders are the patients. So I know that ultimately it all boils down to the customer or to the patient, where we have to decrease the risk of fatality, we have to reduce overall amount spent in their healthcare, and then finally improve their overall healthcare hospital and providers and manufacturers experience, right? So these are the respective problems we have to solve using data analytics. These are being solved using non-data analytics solutions as well, but definitely with the advancement of predictive analytics, machine learning, and similar data related technologies, a lot of these problems are being solved in a better way and a professional way nowadays in the industry. Okay, so let's go deep dive into the healthcare analytics. So healthcare analytics is about R&D of the clinical data, and it is about checking what all possibilities are there for collecting EMRs, EHRs, and collecting sentiment data of patient behaviors and preferences and their purchases. So when we have all this data collected in, then definitely we need analytics on top of the data. Otherwise, we are wasting the data we have collected from these wide range of sources, right? So therein, healthcare analytics come in with different use cases we'll talk about. But for now, let's understand what is the grow so as growth of the industry. If you see, the healthcare is 10% of the GDP of the population, and then we are from the healthcare analytics is about expected to grow 31 billion by 2022. That means it's a really big industry across the United States itself. Then we are having like more than close to 190 countries, where in each and every country, definitely large portion of the GDP is on the healthcare, and definitely billions are being spent on healthcare analytics as well, to improve the overall experience of all the three primary stakeholders of the healthcare industry, right? So let's in brief talk about some of the use cases. So we'll first talk about a few use cases at a whole, and then we'll deep dive into one of the use cases where we'll try to predict cancer. So let's start with the use cases of healthcare analytics in the healthcare industry, right? So let's talk about the medical image analysis first. So if you see, medical image analysis is the most promising applications, which aims to detect tumors, arteries, stenosis. So stenosis means blockage of the arteries, organ delineation. Different methods and frameworks contribute to the medical imaging in various aspects. So I know that there are devices which can show like do some imaging and show the reports to the doctor. But what if not only do the imaging, but also kind of predict that, okay, if you are seeing stenosis or not in your artery, is there a blockage in the artery? So sometimes what happens specifically for the artery stenosis is the doctors are not able to fully predict the exact percentage of the blockage. All right, so there the medical image analysis analytics comes to being, where the applications, the data being collected from wide range of machines which do this sonography, and all the tests are processed through different algorithms to predict or to completely analyze at a very highly accurate level that, okay, this is the percentage of blockage, and this is the exact issue. So if there is a tumor, sometimes some tests are not able to kind of detect the tumors, right? So but by doing the analytics on top of the images, we can definitely do this analysis better, and it will help not only the doctor but also the patient to understand their exact problems, which can be cured easily. Okay. Then let's move to the second use case. So if you see, it's about genetics and genomics. So it's about understanding the DNA. So a lot of diseases are because of hereditary reasons and DNA reasons, right? So definitely the DNA contributes a lot, because the genetics are contributing to the diseases and the response to medicines of a particular patient. So taking an example of a patient whose family history is having diabetes, right? So we see that it's very normal. The diabetes and obesity is a genetic disease which can carry on forward to generations and generations altogether, right? So definitely the healthcare analytics as a whole is able to understand that, okay, these are the genetical reasons, whether a particular disease is definitely due to a DNA or a genetic reason, or it is due to some other factors, right? So the diagnosis of the disease improves a lot, because the doctor understands that not only that there can be a reason of genetics, but also there can be any other reason. Suppose in this use case, we analyze the DNA of the patient and the family of the patient, and see that not necessarily the disease is because of the DNA, because for example, seeing the DNA of their parents and the child's DNA, they don't see the reason of a child suffering from say a cancer or something, some disease is due to the genetic reason or DNA reason, right? So definitely this was not possible before we had data analytics into place. So as long as the data analytics has matured, the understanding the impact of the DNA on our health has improved a lot, which has improved the curability of a disease a lot as well. Okay, so hope everyone is understanding everything. We'll have last 5 to 10 minutes to take the questions. You can put your questions in the chat box. Okay, so coming to the third use case, where we talk about creation of the drugs, right? Creation of medicines for a particular disease. So definitely there are years and years of experiments been done, some ranging to 15 to 20 years as well, to arrive at a particular combination of a compound that will cure a particular disease, right? So instead of experimenting on on guinea pigs, or on guinea pigs, or say some samples on some animals or some other sample patients, what can be done is the using advanced analytics, mathematical modeling and simulations, we can know that okay, how a particular compound will react to a particular type of body, right? So in that way, many things are impacted. One is the people or the animals who have been impacted for the creation of drugs and have been suffering because of that, that will that can be reduced a lot. And then secondly, when we talk about the years and years spent to do these experiments, because when you involve a living thing like animal or a person, they tend to show results after a period of time, right? It's not running a computer program that you run the program and you get the result in 5 to 10 minutes. It's like days on days of lab experiments, which can take years altogether for coming up for a particular disease medicine. Okay, so since we can automate and simulate the reaction compound index in a particular body, then the dependency on the time and impact on the health of people is reduced. Okay, so definitely this is one use case where the human rights people will also be very happy about. Then going to the predictive medicine use case, so not only we can tell okay, this is how you create a particular medicine faster and better way, but also if somebody is going to suffer from some disease in the future, data analytics is able to predict that based on their symptoms and the clinical notes. We can find correlations and associations of the symptoms, antecedents, habits, and all the diseases, because we will have a wide range of data where we'll find out, say, a particular person who is having a sedentary lifestyle and is not exercising much and is eating a lot of junk food, for example, is bound to suffer from, say, diabetes. Then definitely we can predict that okay, if he is not suffering now, if he continues, then we can definitely see that he or she can suffer from diabetes in the future. So based on that, the diagnostic accuracy of a doctor or a provider is increased, and predictive medicines and predictive corrective measures and alerts are sent to the particular patient, so that they either correct their lifestyle, or they take their predictive medicine to prevent a particular disease in future. So definitely this is also a very good use case for people who are suffering from lifestyle diseases mainly. Okay. Then coming to the use case of virtual assistants for patients and providers, patients and customer support. So if you see the optimization of clinical processes, which are very slow in nature, sometimes or very cumbersome in nature, are upon the concept that many cases is not actually necessary for the patients to visit doctors. So what happens is when uh, a follow-up, a particular patient goes to the doctor for the first time, and the doctor recommends a particular medicine, say of say gastric ulcer. Okay, so the doctor has kind of diagnosed that a particular person is suffering from gastric ulcer, and the doctor gives a medicine of say power 10 mg for a start, and then he says that uh, okay, if you can consult me if there is any problem. Then what happens if the patient is not feeling better after taking the medicine? The patient goes to the doctor, and then doctor just what the doctor does is he or she increases the mg to from 10 mg to say 50 mg or 25 mg, just increases the power of the medicine, because they understand that the diagnosis is clear, but the only thing is the power of medicine needed is higher. So what happens in that case is there is a kind of inconvenience for the patient, inconvenience for the doctor, and also like uh, at the end it's a like a losing situation for both. So if we can optimize the clinical process, and we can say that okay, I will give you a virtual assistant, so that if you are not feeling better after the medicine, then just increase the power of the medicine. Of course there will be data backing to it. It's not like always you just blindly increase the power. Definitely the virtual assistance will have its analytical engine in the background, and based on the analysis of the data provided by the patient, the virtual assistants will kind of show to the patient that okay, based on your data inputs and all the diagnosis being done, you have to increase your medicine intake to the this particular 25 mg or 50 mg respectively. Okay, so this is how we improve the overall experience of the patient, so that he or she doesn't have to visit to the doctors, or he or she doesn't have to get tensed out if a uh, particular medicine or a particular diagnosis they think is not working fine. So definitely basic questions and basic solutions can be handed over to the virtual assistants for patient and customer support, right? And customer support, definitely not talking about these cases where they recommend, but customer support for booking hospitals, customer support for operations of the hospital, payments and finance and everything can be automated using data analytics use cases. So definitely this is also a application of data analytics in the healthcare industry. Okay, so I hope everything is being understood by everyone. Please put your questions in the chat box. If you have some questions, I'll try to answer at the end of the session. Okay, now going to the next use case of social media analytics. So, social media analytics is all about various types of analytics can be performed on the data, where the sensing and network analysis can be done for a person who is suffering from some mental illness. That what is their activities on the social media, and what do they do in the social media every day. So based on that, a particular psychiatrist or a psychologist can monitor their activities, and they understand the trends and patterns of the customer using the social media platform, and based on that they can understand their behavioral patterns to figure out their exact problem, right? So these can be improved using data analytics on top of the social media data. And then secondly, uh, sentiment analysis, basic sentiment analysis. If a hospital or a product wants to do the sentiment analysis, suppose Philips launches a particular machine for as a hearing aid to people who have hearing problems and they want to know, okay, so I have launched this in the market recently. What is the sentiment about this? So definitely they can pull the social media data based on the keywords of their product names, and based on the positive and negative and neutral sentiment, they can understand that how their product is performing from the customer point of view. So definitely the social media analytics is a very good use case in the healthcare industry. Last use case from these wide range of use cases, we'll talk about business process analytics, where optimization of the process and performance improvement is done. So it's like this is a generic kind of generic use case which is applicable not only on the healthcare but also on all the industries. So it's more about optimization of the performance, right? So just giving a brief overview of other use cases. So we can risk scoring, we can do the risk scoring of chronic diseases of the population health. We can avoid 30-day hospital readmissions using patients' risk factors and understand their likelihood of a particular readmission risk. We can get ahead and understand the patient deterioration, especially when they are in non-ICU units. So whether to shift them to ICU or not by checking and doing regular real-time analytics on the patient vitals, right? So definitely getting ahead of patient deterioration can be done using data analytics. Forestalling appointment no-shows using predictive analytics can be done. So there are various apps nowadays which we can use and book appointments, but most of the appointments go unnoticed, or no-shows happens from the patient or the doctor perspective. So we can predict that, okay, where there is a high likelihood of a no-show by a doctor or the patient, we can send an alert to them so that they can increase their they can have a better experience altogether. And then finally, we have predicting the patient utilization patterns. So when we talk about the CDA systems, which are able to predict patient response to certain course or treatment by matching genetic information with the results. So definitely, this is also a good use case for a particular customer. Okay, so these were the use cases. Now let's talk about the implementation part of it, the technical part of it, I would say, right? So technically, there are basically five phases, the five main phases where we define our data analytics project objective. What is the specific business problem, how to solve it, then acquire and explore data, then model data, then interpret and communicate the data to the stakeholder, and finally implement it and document and maintain it in the production environment, right? So just I'll give a brief overview of each of these each of these sections mainly. So let's start with project objectives, where we specify the business problem. We acquire the subject matter expertise. By subject matter expertise is if I'm talking about solving medical patient adherence to a particular medicine use case, then I would understand how pharmacies work, how patients in pharmacies work, and what are the different problems faced by the pharmacies and the patients dealing with the medicines from the pharmacies, right? So these expertise is definitely needed from the business perspective as a part of defining the project objectives. And then we prioritize the modeling criteria, we consider risk and success criteria, we decide whether to continue on the project objectives or not. So all these are definitely pain points before starting a particular project. So without understanding all these, prioritizing the modeling risk, success or failure, whether to continue or not, so these all are needed to start the project. And once everything is clear that, okay, this is the business problem, these are the list of data sets I want to acquire, and this is the end solution I want, then I can go ahead and find appropriate data, merge the data into single table by doing some data pre-processing, merging, joining, and doing some basic cleaning of the data, right? So this will definitely help. And after the cleansing and pre-processing is done, we definitely conduct exploratory data analysis to find patterns and behaviors of the variables in the data or the parameters in the data, right? So this is definitely helpful for going to the modeling step. So once we understand the data and the factors which are affecting the outcome of a particular business use case, then definitely we'll be able to model or predict. Suppose I want to understand how many patients or a particular patient is suffering from cancer or not, or there is a risk of suffering from cancer or not. So what do I do is I merge the data into single table. I conduct exploratory data analysis, and I understand that, okay, when the patient is for example having, this is the diameter, and this is the kind of other parameters uh, of the cancer area of the customer, of the patient, then definitely I'll be able to model that, okay, this, if this happens, that okay, if I find a bigger size abrasion in the customer's skin, then this is a high likelihood of having a cancer, or as compared to a smaller one, for example, right? So I can understand that, okay, what all parameters are important, whether a customer living in a particular area of the country is important, or whether what the customer is eating, the diet of the customer is more important for predicting the risk of cancer from a customer perspective. Okay, so definitely this is the second step which is helpful. Then we have the modeling of data, where we select various variables. We build candidate models, we validate and select the best model out of it. So it's not about just building one model and completing your analysis. We have to, as the advanced analytics professional or a data scientist, we have to find out there are different types of solutions to the same problem, and which is the best solution, so that the highest accuracy is achieved while predicting a particular solution, or while solving a bigger problem, right? So the model validation selection phase come into help in that phase. And then we have interpreting and communicating the model. So it's sometimes what happens is we model the data, we get some accuracy, but the stakeholders are not able to understand that how are we predicting. So non-technical people or non-technical stakeholders are having very less overview of what is analytics all about, right? So for them, what we have to do is we have to understand that if we have created, say, a random forest model or a boosting or bagging model, then we have to make the stakeholder understand that what I am doing is I'm finding correlation between these. I'm dividing the data sets into multiple parts, and these are the important parts, these are the not so important parts. I am using the important parts to find the correlation between the outcome and these important parameters, so that my accuracy of prediction or solving a problem is increased to the highest possible limit, right? And then finally, once everything is set and you have communicated and the stakeholder accepted your solution, then it's a time to document it and maintain it and deploy in production. So it's not about only just creating the model and forgetting about it, but it's setting up a system, a continuous system in place, so that for example, if I am predicting a cancer, so every time I am at a I am a cancer hospital and I have built a cancer detection system. So every time what I do is I pass a customer through this advanced analytics use case system before going to the doctor itself, so that the doctor is getting the report of the analytics system before making the diagnosis, which will help the doctor a lot. We'll see in that in detail when we talk about the cancer prediction use case. And finally, maintaining. So time and again we'll be keep on getting new data into our model. So definitely we have to keep on increasing the accuracy of the model. So It's like we have to feed the new data set as a training data into the model. Otherwise, model will not be able to learn new trends and patterns in the data. So if you keep a stale data or old data, the model will give you a faulty result, because the pattern of say patient has changed over the years, and the pattern of healthcare of the patients has changed over the years. So definitely we have to keep on adding new data time and again for implementing, documenting, maintaining the model. So let's deep dive further into the architecture used in the healthcare industry. So not only we have say not only we have the 5 steps I talked about, but also we have to understand that what are the different tools and techniques or technologies being used in those 5 steps. So this is a high level architecture for healthcare solution for analytics in an enterprise. So what happens is data is collected based on the use case. So this is a holistic view of it's a generic and holistic view of many use cases. So be it a use case of predicting a cancer, or be it use case of predicting adherence to a medicine by a customer or a patient. Uh, but the tools and techniques remain the same. So let's go from left to right. Okay. So when we see about the from the left, we have data from the pharmaceuticals, patients, doctors, hospitals, and machines. So as I told, these are the primary stakeholders of generating and consuming data, right? So definitely they will consume the data as well as they will generate the data too. So these data can be from the cloud, can be internal sources like database, apps, files. These can be from external sources as well, from databases, from external system, from third party applications, or some other vendor sending us a flat file or a CSV file. So these the formats or structure of the data will vary from source to source, depending on the pattern or on the type that source is storing the data from, right? So our system in an enterprise should be capable of handling all the types of sources, be it internal source or external source, or cloud source, right? So definitely this will be helpful. Then coming to more sources, types of sources, we can have unstructured data coming up from some machines, some sensors, some IoT devices, and altogether we can have data coming from social media like Facebook, YouTube, Twitter, LinkedIn, blogs, etc., etc., right? And then finally, we can have data coming from web portals as well. So web portals have unstructured data in form of HTML data, right? But if you want to make the data much and much at aggregate level, then we have to collect and pre-process and analyze the data, and then finally draw conclusions from it, right? So definitely these are the sources all the enterprises have to solve any kind of use cases. And then coming to the fabric or the architecture or tool sets used. So if you see, we have uh, mobiles, reports, self-service BI as the consumers, and then we have machine learning and predictive analytics as the advanced analytics fabric, right? And we have from the cloud data warehouse, all the data is coming into that data science fabric, where data is getting stored in ODS, and then the data master data is being taken, data marts are being created, various types of databases, be it if it is a huge volume, variety, and velocity of the data, then big data technologies can be used to store and process them. But it is not necessarily always that kind of data. So if it's a normal data, we can just use a SQL store or a file-based store, where we just store the data as a file rather than storing in some database management system. And these files are being then processed using tools like R or Python, where data standardization, data discovery, data preparation is done, and finally predictive analytics and machine learning is run on top of it to get the finally the visualization. out of it, right? So this is the data science fabric, or advanced analytics part and data management part of it. So definitely, if you see the three parts, the data management, where we involve the data visualization, virtualization, and federation of the data. So by federation, we mean that, okay, one data is in SQL, one data is in the file, one data is in some other system. But as a consumer, I want a holistic view of all the data together, right? So that is called data federation, where we club in multiple sources into a single UI, and we are able to consolidate all the data and show it to the data analyst for running data analytics on top of it, right? So let's start with the main use case for today. Can data help cure cancer? So we know that cancer is one big mammoth disease which is affecting millions of people every year across the world. And definitely we are science and technology and medicine is improving day by day to do better in cancer, because we have still not reached at the at a state where we are completely free of cancer. Some of the disease like polio and etc., we have reached as a disease that we can say that this particular type of disease has been eradicated from the society and the world. But if you talk about cancer, then definitely it's not that so we have reached to a point that we can say that we have completely cracked on how to cure cancer, or how to solve the problems of cancer, right? So but yeah, definitely data analytics can help cure cancer, and early detection of cancer can increase the survival rate and life quality of a patient with cancer. So the better, the more early you kind of detect a particular type of cancer for a patient, then definitely the patient is going to survive. If you so yeah, everyone knows that there are stages of cancer, like stage 1, where it is fine that they can be cured by giving some medicines or chemotherapy. But when we talk about higher stages, stage 3, 4, etc., the solution of the problem is going down with time, right? So if you see the relative survival percentage from stage 1 to stage 4, it is going completely down in a linear fashion. So definitely the more earlier you predict, the better it is. So how to solve this problem on predicting cancer as soon as possible using data analytics, right? So let's understand at a high level first. So firstly, assess and predict who is at most at risk of developing cancer. Who is, if a particular patient, if there is a bunch of patients coming in, then who are the list of patients who are at the most risk of adverse event in the near term? And then identifying what are the influencers or data driven factors that are materially affecting the cancer levels. So if the lifestyle of the patient is affecting, or if the kind of diet is affecting, or if some external factors like the area the particular person is living is just beside kind of industry, a wide range of industrial area, definitely that can also be an influencer or a factor of affecting the cancer levels, right? So we have to identify what are the influencer and data driven factors to do that prediction. And then matching people's risk with tailored interventions. So how we can adjust programs to target based on different risk levels. So if a particular person is at stage 1 versus stage 2 versus stage 3, we cannot give the same medicine or the same cure to everyone. So definitely we have to understand as a data analytics professional that okay, uh, it's fine that we have predicted cancer as soon as possible. So based on the above results, we have to start sending alerts. So once we know that okay, the particular person is in stage 1 or stage 2, we can send alerts and corrective actions to the people. So what they do is there is a high chance that if we don't send alerts or corrective measures in the stage 1, the person is not showing the symptoms, and he or she is feeling very good about his or her health. So they kind of take it for granted, and they don't take medicines prescribed by the doctor, or they don't take uh, precautions and measures to cure the disease, right? So definitely early detection of cancer can help, and this is the way we have to solve the problem by understanding who is at risk, by checking what are the influencers for uh, sending interventions and alerts and offers and corrective actions to the people, so that at the end we reduce the mortality rate or the fatality rate of cancer from the world, right? So definitely we understood that data can help cure cancer. So let's go deep dive into how it can help, right? So if you see, I've created this particular slide to make you understand through a personal persona use case. So Mary is a 41 years old lady who is suffering from chronic back pain and abnormal skin conditions, and has been diagnosed that skin conditions she has can have a potential risk of cancer. So what she does is she goes to the doctor with symptoms of cancer, and the doctors then prescribes collects critical data, healthcare, and prescribes medicines. The system records the data and fits into the patient analytics system, and the system detects that whatever data medicine was prescribed versus the patient analytics system has predicted that she has stage 4 or a stage 2 cancer. Then she needs to take another set of medicines, right? So she has a high possible risk of cancer, so she has to change her medicine. So when the system detects Mary is not reaching out to the doctor to change the medicines, it raises a trigger alarm to make a visit by sending not only alerts, alarms, uh, uh, but also promotions and offers to create a sense of urgency to the patient, that okay, he or she has to, or in this case Mary has to go to the doctor as soon as possible to cure a potential fatal cancer which she might be suffering from, right? So corrective measures has been taken from by Mary, and she went to doctor, and doctor prescribes the relevant medicines. So by this way, end-to-end way, we saw that how Mary is able to cure her cancer, right, by detecting the cancer at a at a much earlier stage, rather than just visiting the doctor time and again and getting no outcome out of it, right? So this is how it works. Let's see a live demo or a kind of an example where we are predicting a breast cancer for a particular patient. The data is something like that. We have 570 instances which is having the diagnosis whether the breast cancer is malignant or benign, and what is the radius mean of distances from center to the point. So this is the imaging result of a cancer. The breast cancer examination has been done, and the radius mean, texture mean, perimeter mean of the tumor lump developed by Mary has been taken into account, and the smoothness mean and the compactness mean has been taken into account to see that whether it is a malignant or a benign. So definitely a malignant cancer that means that Mary is at less risk, and benign means Mary is at a high risk of developing cancer, right? So how it's done technically. So collecting all these 570 instances of 6 attributes, we put the data into a pre-processing code and then after the pre-processing, a math model is being run for predicting the classification of the cancer of Mary being a malignant or benign by running logistic regression, or say kind of random forest, or a boosting or a bagging model. And then finally prediction outcome is given to Mary, so that she knows that what type of cancer what stage of cancer she is in, right? So as we already know that the pre-processing steps and the predictive modeling steps has all these points where we say that treat outliers, remove the missing values, do feature engineering, find out what all factors are important, what all parameters are not important, create a dependent variable. So in this case, the dependent variable is the diagnosis, the end result, whether malignant or benign, and independent variables are the dependencies on top of which the diagnosis is done, right? The radius mean, texture mean, and all that is are independent variables, and all other variables are not required, so we can drop them. So by that we can do the processing, and then finally on the pre-processed data we can run a predictive model, for example random forest, to get the result. So let's check in the example using Python. So if you see at the bottom of the screen, this is the data set where we have ID, diagnosis, M means malignant, B means benign, and then radius, texture, perimeter, and all that stuff, right? So we import the data using Python library pandas, and then we can use another library called sklearn to kind of import the sklearn training and test split classifier, and then we have random forest classifier from the sklearn package. We import the data from the data URL, we read the data and create a data frame out of it, and then we split the data into training and testing. Training data is the data which is used for creating a model, and testing data is the data which is used to checking the accuracy of our model, right? So that's why what we are getting is all the data which has been received from the stakeholder is being divided into 80% of training data, 20% of testing data. And the training data is taken into account to create the model. So if you see, we have used random forest classifier, where we have 100 estimators and -1 jobs. So these are the various parameters to create the number of trees. So number of estimators means number of trees in the random forest uh, estimator, right? And then my model dot fit means we are fitting the model based on the training data. As I said, we are passing X is the independent variable list and Y is the dependent variable data. So we are passing both the data to create a random forest model, and then finally we are predicting the outcome on the test data. So if you see this part of the code, the last but one line of the code, we are predicting the result of cancer being malignant or benign using this model.predict function. And finally, we can print the accuracy score. If you see metrics dot accuracy underscore score, so what is the accuracy? So what is accuracy from the technical perspective? The number of correct predictions of benign plus number of correct predictions of malignant divided by the total number of rows in the data sets is the accuracy. Okay, so we can get accuracy from this function. And finally, let's come to the deployment part of this. After we have created the models and checked the accuracy, and we have explained the model to the stakeholder, we have to deploy the model in production so it can run and predict with time and again. So we can use for example any of the cloud services here. In this example I'm using the Azure machine learning services, where I'm taking all the data from SQL. I'm passing through a service of Azure called ML Studio, where I'm just running the same code again and again to predict the cancer. And finally the result of the code is going to website, to the mobile as an alert to the patient and the doctor, to the website to generate a report of how many people are suffering from malignant versus how many people are suffering from benign cancer. And finally maybe some Excel based reporting can be done to the leadership as well, right? So all this can be done using ML services. So if you see, if I walk through the code, the Azure services have services.publish, where we take the workspace ID and workspace token. We can we can pass the different data of texture means. These are the independent variables which are coming from the new patients coming into the system. Like Mary, there can be other people coming into the system. So for each and every people, we have to predict whether what is the possibility of they having a cancer, right? So they can pass their respective parameters here, and finally we can run this predictor where we do model.predict and we pass this data sets. and these service URLs and API keys will help you connect and give the result. So if you see this breast cancer predictor.service, we are passing this result and we are getting a result of M or B out of it. Okay, so for this particular, say this is the vitals, or these are the readings for Mary. So if Mary is suffering from, say, benign cancer, then she can be able to know by passing the parameters, and she will be right away getting the result. Okay, so this is the accuracy report I was talking about in the previous slide. So if you see, this is the classification result that, okay, I have 75% accuracy of what I am predicting. So it's like data analytics is always dependent on accuracy on which we predict, right? So it's not always we are able to predict 100% correctly. So definitely there is an accuracy level. So we have to communicate that to the stakeholders. To get that, we have to run this metrics dot accuracy score to get the accuracy out of it, and definitely this will help in getting cancer result, right? So yeah, I think yeah, that's what we I wanted to show you. So we understood how cancer is predicted and how corrective measures are taken to cure the cancer, right? So we understood what is healthcare, what is healthcare analytics industry, what are different use cases. We walked through many use cases and we walked through the implementations, and finally we walked through the main use case of cancer prediction using advanced analytics using Python and Azure environment. Okay. So let's start by answering the questions you have. We can start pitching in with questions. So let me read out the questions, and then I'll also give you the answers. Yeah, I can see the question right now. DNA is unique for individuals. So do we collect data and do analysis on that? So yes, DNA is unique for individuals. So definitely we use individuals' DNA data. As I said, individuals versus family here. What are the DNA of a particular individual, and what is the DNA of the family, and how particular DNA is affecting the cause of the disease a particular person is suffering from. Okay. Going to the next question. So is it necessary to have knowledge about healthcare terms and technology for data analytics? Definitely not, Vinay. So it's not necessary that you always need to have knowledge about healthcare terms because, as I said, data analytics is across industries. So it doesn't matter that today we are talking about healthcare, but if you are in some other industry, say automotive or oil and gas or insurance, etc., etc. So in all the industries, almost all the industry, we have major applications of data analytics. So definitely knowledge about one industry is not needed. Okay. Okay, so next question, Farisa asks, what are some resources that can help me quick start and with data analytics? So definitely, Imarticus, you can consult with the counselors here in Imarticus, and they can help you and getting the resources and helping you out for a course in data analytics. You can start with, and online resources are very much available for getting hang of it on what are the different topics in detail, so that you understand what are different resources. So what are different topics in data analytics. Okay, next question. Can you please explain machine learning in healthcare, or are Python analytics will suffice? So yes, when you so R or Python. So if it's a question about whether to choose R or Python, so both tools are very good, popular in the market. The requirement in the industry is for both the tools. Having said that, Python is rather a programming language which is not meant only for data analytics, but for wide range of applications like full stack development, backend development, front end development. But R is a language which is specifically concentrated on processing and analyzing data. But having said that, the requirement industry is both. You can choose any of the tools to start with. Yeah, next question by Sadhana: is mathematical modeling and simulation not available without data science? See, data science is a big umbrella term where mathematical modeling and simulation is also a part of it. So not only the prediction or predictive algorithms like classification, regression, and clustering is included, but also mathematical modeling for simulations uh, and optimizations are also included in the data science field. Okay. Next question. Where can I find healthcare data sets like the one used above? Farisa asked this question. So definitely it can be found in various open source websites. So if you just search on the internet cancer data, right? So just search on the internet cancer data for prediction. So you will get a lot of data sources for the same data source I used. Okay. So it's very easy to find it out. If you want the link, I can share with you as well. Next question by Preetham, could you please briefly substantiate the flow of architecture part with an example? So I think I explained that. Let me reiterate briefly. So if you see the architecture, it starts with collecting all the data, and collection can be done using various tools like SQL or R itself, and acquiring and exploring data is done using R, and then R or Python. Then modeling data, definitely R and Python. And then we have interpreting and communicating. This is a more of a work from PowerPoint presentations and PPTs and documentations in various. So you can write a Microsoft Word document or create a Microsoft PowerPoint presentation to communicate your insights. And finally, you can use a cloud environment like Azure or AWS to implement and deploy the model in production. Okay. So I'm a doctor. What is the career path? Shashidhar asked this question. For yes, like I have seen a lot of people changing their career paths from non-technical backgrounds to data analytics. So definitely, that doesn't mean that if you are a doctor, you cannot go into data analytics part. Definitely, as you saw, that there are wide range of applications in the healthcare industry. You can pick any one applications, and you can associate with the hospital in their analytics department. So every hospital has a technical department. So you can communicate to one of the hospital's technical department, and you by acquiring the skill sets, you can go to them and say that, hey, I can solve the problem using my skills of data analytics. So definitely a career path is there, and it can go from joining as a data analytics professional to the CTO of a company. Because most of the companies are right now revolving around data, because data is the new oil nowadays. So next question. Can geography be considered for analysis for like some city or country or industry? Definitely, Vishal, we can consider geography or other demographic patterns of a particular patient or a customer, because that might be the reason for a particular outcome of a problem, right? So definitely these are the variables which are dependent on the outcome. So we have to consider those for sure. Okay, so Ravi Kumar asked that you have shown the model used as random forest, which has derived of 75% accuracy. How can we decide the model and accuracy percentage? Yeah, good question, Ravi. So for this question, I can say that now I have used only one to just showcase to you on how it is done. But definitely in real world scenarios, not only random forest is used, but logistic regression, bagging models, GBM model, boosting models, XGBM models is used. A wide range of neural networks and other advanced machine learning can be used to understand if we can get better accuracy. So this particular random forest example was just for learning purpose, but definitely there can be better algorithms which can give higher accuracy. So the more the accuracy, the better the model is. So definitely you can, as you know, accuracy is the number of correct predictions divided by the total number of data points we have. So based on that, we can decide which model to choose. So yeah, Siddesh asked, is data analytics is a good option for digital marketers? Definitely yes. So since there are a lot of applications of data science in digital marketing as well. So if you see Facebook ads or Google ads are all our background, the backend is on data analytics for understanding that how a customer should be targeted, what is my potential audience, what is the sentiment of my potential audience about my product. So definitely data analytics is definitely a added advantage for a digital marketer to have. Okay, so next question. Ishan asks, have no coding background. In which particular direction should I plan to move in data analytics industry? Definitely, Ishan. You can, by choosing tools like R or Python, or there are some point and click tools available in the market today. Even if you don't have full range of coding experience, that doesn't mean that you cannot come into this field. You can definitely try your hands out, and definitely it's not that difficult subject to learn altogether. How about scope of data analytics being a fresher? So I think it's already answered. I think it's been answered already. So next question. Pushkar asked that what do you think I should focus on to get a job in healthcare industry as I'm a web developer? See, Pushkar, it doesn't mean that you join the healthcare industry if you are reading data analytics. As I said, data analytics can be applied across industries. You can choose any industry of your choice. But yes, as a web developer, you can switch your career to data analytics in any industry of your choice or experience. Thank you.